Nails and screws, when employed as a fastening method, must comply with particular stipulations. They must either be affixed utilizing brackets positioned on the exterior of the enclosure or traverse through the interior, maintaining a proximity of 6 mm or 1/4 of an inch to the rear or terminal segments of the enclosure. This regulation ensures the structural integrity of the electrical enclosure and mitigates the risk of accidental contact with energized components within. The choice between utilizing brackets on the outside or passing the fasteners through the interior hinges on several factors, including the enclosure's design, the available space, and the specific application. When opting for external brackets, it is crucial to select brackets that are appropriately sized and rated for the load they will bear. The brackets should be securely attached to the enclosure using appropriate fasteners, such as bolts, screws, or rivets, ensuring a robust and reliable connection. The material of the bracket should be compatible with the enclosure material to prevent corrosion or galvanic reactions that could compromise the integrity of the connection. When passing fasteners through the interior, maintaining the 6 mm or 1/4 inch proximity to the back or ends of the enclosure is paramount. This minimizes the risk of the fasteners protruding into the internal space of the enclosure, potentially interfering with the electrical components or creating a safety hazard. The fasteners must be of sufficient length to securely fasten the enclosure to the mounting surface while adhering to the proximity requirement. It is essential to select fasteners that are compatible with both the enclosure material and the mounting surface to prevent corrosion or other forms of degradation. The type of fastener used, whether nail or screw, depends on the materials being joined and the desired level of holding power. Screws generally provide a stronger and more reliable connection than nails, particularly in applications where vibration or movement is a concern. However, nails may be suitable for lighter duty applications where ease of installation is a priority. When using nails, it is important to select nails of the appropriate length and gauge for the materials being joined. The nails should be driven straight and flush with the surface to prevent them from protruding and creating a hazard. When using screws, it is important to select screws of the appropriate length, diameter, and head type for the application. The screws should be tightened to the proper torque to ensure a secure connection without stripping the threads or damaging the materials. In addition to the physical attachment of the fasteners, it is also important to consider the electrical safety aspects. The fasteners should be made of non-conductive materials or insulated to prevent them from becoming energized and creating a shock hazard. If conductive fasteners are used, they should be properly grounded to ensure that any fault current is safely conducted to ground. The selection of appropriate fasteners and attachment methods is crucial for ensuring the safety and reliability of electrical enclosures. Adhering to the guidelines outlined in the electrical code helps to prevent accidents, protect equipment, and maintain the integrity of the electrical system. Furthermore, it is essential to consult the manufacturer's instructions and relevant industry standards for specific recommendations on fastener selection and installation procedures. Proper installation techniques such as pre-drilling pilot holes for screws and using appropriate driving tools can significantly improve the quality and durability of the fastener connection. Regular inspection and maintenance of fasteners are also important to identify and address any signs of loosening, corrosion, or damage. Replacing damaged or corroded fasteners promptly can prevent more serious problems from developing. In summary, the proper fastening of nails and screws in electrical enclosures is a critical aspect of electrical safety and system integrity. By adhering to the guidelines outlined in the electrical code, selecting appropriate fasteners, and following proper installation procedures, you can ensure a secure and reliable connection that protects both personnel and equipment. The importance of maintaining the 6 mm or 1/4 inch clearance cannot be overstated. This small distance plays a significant role in preventing accidental contact with live electrical components. When installing fasteners, it is recommended to use a measuring tool to verify that the clearance requirement is met. This simple step can help to avoid potentially dangerous situations. Moreover, it is advisable to use fasteners that are specifically designed for electrical applications. These fasteners often have features such as insulated heads or corrosion-resistant coatings that enhance safety and durability. When working with electrical enclosures, it is essential to prioritize safety at all times. Always to energize the circuit before performing any work on the enclosure or its components. Wear appropriate personal protective equipment such as safety glasses and gloves to protect yourself from potential hazards. If you are unsure about any aspect of the installation process, consult with a qualified electrician or electrical inspector. Their expertise can help you to ensure that the work is performed safely and in accordance with all applicable codes and regulations. The long-term performance of the fastener connection is also an important consideration. Factors such as vibration, temperature changes, and exposure to moisture can all affect the integrity of the connection over time. Selecting fasteners that are resistant to these factors can help to extend the life of the connection and reduce the need for maintenance. For example, using stainless steel fasteners in corrosive environments can prevent rust and ensure a long-lasting connection. Similarly, using vibration-resistant fasteners in applications where vibration is present can prevent loosening and maintain a secure connection. The proper fastening of nails and screws in electrical enclosures is not just a matter of following code requirements, it is a matter of ensuring the safety and reliability of the electrical system. By paying attention to the details and taking the necessary precautions, you can help to create a safe and efficient electrical environment. Remember to always consult with qualified professionals and adhere to all applicable codes and regulations when working with electrical systems. Their expertise and guidance can help you to avoid potential hazards and ensure that the work is performed safely and correctly. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before performing any electrical work. Their expertise can help you to ensure that the work is performed safely and in accordance with all applicable codes and regulations. The selection of the appropriate type of nail or screw is critical and depends on the specific application and materials involved. For example, when attaching an enclosure to a wooden surface, wood screws or nails designed for a wood application should be used. These fasteners typically have a coarse thread or shank that provides a strong grip in the wood. When attaching an enclosure to a metal surface, self-tapping screws or machine screws with nuts may be used. Self-tapping screws create their own threads as they are driven into the metal, while machine screws require pre-drilled holes and are secured with nuts on the back side. The material of the fastener should also be considered. Steel fasteners are commonly used for general applications, but stainless steel fasteners are preferred in corrosive environments. Aluminum fasteners are lightweight and corrosion resistant, making them suitable for certain applications. Copper fasteners are often used in electrical applications due to their excellent conductivity. The size of the fastener is also important. The diameter of the fastener should be appropriate for the size of the hole or bracket being used. The length of the fastener should be sufficient to provide a secure grip without protruding excessively from the back of the enclosure. When using screws, it is important to use the correct type of screwdriver or bit. Using the wrong type of tool can damage the screw head and make it difficult to tighten or remove the screw. Power tools can be used to speed up the installation process, but it is important to use them carefully to avoid over-tightening the screws or damaging the enclosure. When using nails, it is important to use a hammer of the appropriate size and weight. The nail should be driven straight and flush with the surface to prevent them from protruding and creating a hazard. It is also important to avoid bending the nails over, as this can weaken the connection. The proper installation of nails and screws is essential for ensuring the structural integrity of the electrical enclosure and preventing potential safety hazards. By following these guidelines and consulting with qualified professionals, you can ensure that the fasteners are installed correctly and provide a secure and reliable connection. Finally, remember to document the installation process. Keep a record of the types and sizes of fasteners used, as well as the locations where they were installed. This information can be helpful for future maintenance or repairs. It is also important to label the enclosure clearly, indicating the voltage and amperage of the circuit it contains. This can help to prevent accidental contact with energized components and ensure the safety of personnel working on the electrical system. The adherence to the 6 mm or 1/4 inch rule is not merely an arbitrary code requirement, it is a fundamental safety measure designed to protect individuals from potential electrical hazards. By maintaining this clearance, the risk of accidental contact with live electrical components is significantly reduced. This is particularly important in situations where the enclosure may be subject to vibration or movement, which could cause the fasteners to shift or loosen over time. In addition to the physical safety aspects, proper fastener installation also contributes to the overall reliability and performance of the electrical system. Loose or corroded fasteners can create a high resistance connection, which can lead to overheating, voltage drop, and even electrical fires. By ensuring that the fasteners are properly installed and maintained, you can help to prevent these problems and ensure the long-term reliability of the electrical system. The electrical code is constantly evolving to reflect the latest advancements in technology and safety practices. It is important to stay up to date on the latest code requirements and to consult with qualified professionals when performing any electrical work. By doing so, you can help to ensure that the electrical system is safe, reliable, and compliant with all applicable regulations. Furthermore, it is crucial to consider the environmental conditions in which the electrical enclosure will be installed. In harsh environments, such as those with high humidity, extreme temperatures, or corrosive atmospheres, it is essential to use fasteners that are specifically designed to withstand these conditions. For example, stainless steel fasteners are often used in marine environments to prevent corrosion, while high-temperature fasteners are used in applications where the enclosure may be exposed to elevated temperatures. The selection of the appropriate fastener material is critical for ensuring the long-term reliability and safety of the electrical system. In addition to the environmental conditions, it is also important to consider the type of electrical equipment that will be housed in the enclosure. Some types of equipment, such as transformers and power supplies, can generate significant amounts of heat. In these cases, it is important to use fasteners that are capable of withstanding elevated temperatures without losing their strength or integrity. It is also important to ensure that the fasteners do not interfere with the proper ventilation of the enclosure, as this can lead to overheating and equipment failure. The proper installation of nails and screws in electrical enclosures is a multifaceted process that requires careful consideration of a variety of factors. By following the guidelines outlined in the electrical code, consulting with qualified professionals, and taking into account the specific requirements of the application, you can help to ensure the safety, reliability, and long-term performance of the electrical system. Remember that the information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before performing any electrical work.